Hi, everyone. I'm really excited for this segment because security is the biggest priority here at AWS. And that's the security of for those people using AWS, all of you out there as well. And I wanted to bring on a couple of experts here from AWS to talk about how we secure workloads that are being used in the AWS cloud. So today, joining me are Arvind and Sudhir. Arvind, why don't you introduce yourself and tell everybody what you do here at AWS?
Will do. Thanks, Art. And first of all, thank you for having both Sudhir and me on the show here. We are absolutely excited to talk to the audience about confidential computing and protecting data while the data is being processed. To the audience here, my name is Arvind. I'm responsible for the confidential compute business at AWS. That typically means from our side, focus on the Nitro system, Nitro Enclaves, Nitro TPM, and other compute primitives like AMD, SCV, S&P. Passing it over to Sudhir to introduce himself.
Thanks, everyone. My name is Sudhir. I'm a special solutions architect. My focus area is confidential computing as well, just like everyone. And I work with our ISVs and customers who are trying to solve their confidential computing use cases on a day-to-day basis. So happy to be here.
Thank you for both coming and joining me. So we mentioned the term confidential computing, Arvind. So let's get right into it. I think we should define confidential computing from an AWS perspective and what it means to us so that people understand.
At AWS, we define confidential computing as the capability to protect data from any unauthorized access while the data is in use. I want to stress on this data in use piece here, right? Because when you think about what we do with data, we do three key things. We store data, we move data, and we process data. What we are talking about when we talk about confidential computing is protecting the data while the data is being processed, while the data is in use. The mechanisms to protect data while the data is stored at rest and while the data is moving in transit have existed for a while, and it's pretty mature and customers know how to use it. What we're doing with confidential computing is really extending that protection end to end by providing customers with the capability to protect the data while the data is in use. Why am I
Yeah.
stressing on this so much, right? Like if you think about protecting data while the data is stored or in transit, we expect that customers are already encrypting that data and protecting it.
Well,
Now,
data in that storage is typically automatically encrypted, right? For customers. So, data that's just sitting there in storage, as you mentioned, it's well defined. The question is when it is in that, if you will, unencrypted or exposed state, making sure that there is protection for that asset as well.
that's right. I mean, if you bring encrypted data into your virtual machine and you want to process it, you want to do something with the data, if you want to do it at scale and you want it to be performant with the capabilities that exist today, even state of the art capabilities that exist today, you have to decrypt that data. You have to unpack it, you have to decrypt it, and then process it. What it does to that data at that point is it reveals plain text to entities that are in the VM. And now the question is, how do I protect it? And that's where confidential compute comes in and provides customers with the capability to protect that data while the data is in use.
Okay. So I think from an AWS perspective, we define confidential computing as two dimensions. Why don't you characterize those two dimensions for us? And then I think we're going to show folks a demo of how we can do some of that protection, particularly focused a little bit on that second dimension here.
Sure. I'll talk about the two dimensions and I'll talk about the capabilities that we have to address the two dimensions, and then we can segue, right into that demo to show customers how this all comes to, bring it to action for them and show them how to protect their
Yeah.
sensitive content, right? So when we talk about confidential compute to our customers, we have identified that customers care most about two distinct security and privacy dimensions of confidential computing. Dimension one is where customers want to make sure their content is protected from operators of the cloud provider. In this case, that would be AWS. So dimension one is protection from us. Dimension two is where customers want to extend that protection and make sure even they themselves do not have access to sensitive content that they're dealing with. And when I say content, it could be code, it could be data, and it could be different data types. And I'll touch on that in a minute, right? So customers want to extend that protection, make sure they themselves are protected, their data is protected from them. So dimension one is protection from operators of the cloud provider, and dimension two is protection from themselves. That's the whole dimension there. Now, in terms of how we bring capabilities to address this, Dimension one, where the customer content has to be protected from the cloud provider, is addressed by default at AWS. With AWS, customers have the assurance of no operator access if they're running Nitro-based EC2 instances. What that means is confidential computing is always on by default at AWS. And confidential computing is always on for any of the processors that are in use today. It does not matter if it's a CPU, GPU, or one of our own, accelerators like Inferentia or Trainium. As long as customers use one of these Nitro-based instances, confidential compute is immediately applicable to all of that. We provide those capabilities. And we are the only cloud provider in the world who provide this by default, making sure customers do not have to do anything extra to enable confidential computing to address dimension one. There is
Yeah,
no
so as we
code
talk to
changes.
this,
Yeah,
customers can be assured that what we're talking about in this dimension, the protection of that data in use, is something they get out of box, nothing that you have to do, and it's also free as well, right? So it's included in usage of that. So
correct.
let's talk about that second dimension here, protection from within,
Right.
if you will,
Yeah.
here. And so
So
we can also move as well to bring in Sudhir for the demo portion as well
yeah,
here.
the point you noted there is very important, like for people to understand that if they want to get confidential computing on AWS, they don't have to make any code changes. There is no additional
Right.
cost to do it. You just get it by default, right? Now it's when they start thinking about how to protect that data even from themselves, they get into dimension two, and then they need additional capabilities, specialized capabilities like Nitro enclaves that allows them to spin up a secure execution environment by allocating CPU and memory resources from their own EC2 instances and then process the data inside this environment. Now, when you spin up an enclave, a Nitro enclave, by default, the enclave does not have any external network connectivity. There is no persistent storage. There is no administrative or root user access. There is no way to SSH into an enclave. The only conduit for that enclave to talk to anything external is a secure local channel from which the enclave talks only to the parent instance it got spun up from. So Nitro enclaves, specialized capability, spins up from your own EC2 instance and addresses dimension 2 by making sure even customers themselves don't have access to their sensitive content. So when I say sensitive content, what do I mean? To make it more relatable to everybody, right? It's the different data types that customers have to handle oftentimes, right? PII, personally identifiable information, financial information, digital assets, IPs, right? Sensitive models that people may be using, in the case of AI or in the case of semiconductors, it could be device models or whatever it is that it's considered secret sauce that customers want to make sure nobody ever gets access to. Those are the kind of data types that we typically see customers use inside an
So
enclave.
what I want to do, sorry to interrupt you, is because I think that when we talked with Sudhir a little bit earlier, we had some great like architectural examples of that. So maybe Sudhir, what you can do is bring up that architecture example. We're going to show how you protect language models in this case, or protect some of the access to some of that, but also we'll showcase here. I think in the very first diagram here is somebody is basically you're a client in the client here, you're submitting some information into a large language model. Now, what happens if that prompt and query is actually protected data of some sort? In order to get a valid response from this large language model, you need to submit some information in order for it to provide the best possible response to you. You want to protect that prompt and query from being exposed. And I think what we're going to show here is how you can do this as well.
Like you said, I'm going to just illustrate it a little bit further. If the sensitive information is in the prompts and or the query or the context, that is something that you want to protect. And similarly, the large language model itself, the model weights, if they are fine-tuned and trained on sensitive information to begin with, that is something that you want to protect as well, right? So let's actually take a quick look at how you would use some of the conventional computing capabilities that Arvind mentioned earlier to solve for this, right? So what I have here is a quick, I know it's a busy, but a quick architecture diagram. What I want to draw your attention to is, if you see here, here is that always-on confidential computing environment from a dimension one perspective, the Amazon EC2 instance, right? And what I have done here is I have carved out, like Arvind mentioned, a piece of this parent EC2 instance into an isolated execution environment called Enclave, which is what here on the right-hand side, right? And what I've done further is I have fetched the encrypted model weights from durable storage like Amazon S3 into the Enclave at runtime. And the key mechanism that happens here is cryptographic attestation. By using that with the out-of-the-box integration with AWS KMS, what I have done is I have unsealed or decrypted the model weights and then stood up the LLM server running inside the Enclave, right? Now, once I do that, the client that's going to consume this LLM API, in this case, it's a simple chainlet web application. It's going to run on a distinct compute environment, and what it's going to do is it will perform a handshake to ensure and make sure that it's in fact talking to an LLM endpoint that's inside a Nitro Enclave as compared to just a regular Amazon EC2 instance, right? So that's the key portion.
Just to make sure everybody follows what we're doing here, we talked about cryptographic attestation here. So for the uninitiated on this topic, if you don't know what that means, think about the enclave having the ability to prove its identity to an entity that has secrets that's going to share the secrets with the enclave, right? So that's really what attestation is. It's no different from you showing your ID to somebody to prove who you are. That's what the enclave does. The enclave shows, in this case, KMS, its identity, so KMS can share secrets with it. So there, go ahead.
I want to add one other thing because we've said the word KMS over and over again. The reason there's a key next to it, KMS stands for Key Management Service, which is the entity that is provided by AWS here in this instance. Now that we've shown some of this setup here, do we want to show a little bit about how simple it is to execute this, Sudhir?
Absolutely. Let me actually show a little bit of code just to paint a picture of how simplistic, at least in my mind, how simple it is to take your existing application, in this case the LLM application, package it up into an enclave, and then go deploy it, right? So what I have here is a Docker file. Right? If you're familiar with Docker file, is containerization. The idea here is very simple. The tooling associated with packaging up an application to run inside an AWS Nitro Enclave is container-based. So what we have done is we have open sourced a tool called Nitro CLI. The input to Nitro CLI is a container image. In this case, what I am showing here is a very simple container image. All I have in there is a bootstrap script that's going to do a bunch of things like decrypting the model weights, spawning the LLM server, things like that, right? So I'm just going to call it a shell script, run.sh. A model file is very specific to Olama. Olama is a very popular tool to go run your LLMs locally. In this case, we are using Olama binary. So I actually have a couple of steps to install Olama as part of this Docker file, right? So you get the idea. It's a very simple Docker image. What I'm going to do here as part of my build process is take this Docker file and create an Enclave image file, right? And inside the Enclave image file, the bootstrap script that I mentioned, one of the key things that it does is cryptographic attestation-based decrypt with AWS KMS. So I'm going to just show that line of code which does that. And again, to keep things simple, we have included this CLI as part of our Nitro Enclave's C SDK. It's a C language SDK. And again, it's just a convenience tool. What I would like to mention is this cryptographic attestation with KMS is available no matter which tool you use, right? You could use any AWS SDK of your choice or AWS CLI as well. But yes, this is the one line of code that takes my decrypted weights and encrypted weights, and uses AWS KMS and cryptographic attestation and decrypts them, right? And then finally,
I think, by the way, it doesn't get much simpler than one line, by the way. I don't know that, it's possible to be a lot simpler. So, and Arvind, I think you were also going to say something as well.
Just clarify that the decryption happens in the enclave. So,
Right.
anything that ever gets revealed only gets revealed to the enclave.
Yeah.
And nothing gets out, right? And then
Nothing gets out.
final part of the script is Olama server. So simply what we are doing is using Olama as a tool, decrypting the model weights and telling Olama to serve the LLM endpoint. Just one final piece. So the out-of-the-box integration with KMS that I mentioned, even that portion is by design very simple, right? So what we do is when we create an enclave image file by using this Docker file and Nitro CLI tool, what you get is series of cryptographic hashes, SHA-384 hashes called PCRs. We call them PCRs, Platform Configuration Registers. We take one of the PCRs in this particular example called PCR0. PCR0 is a measure of the entirety of the enclave image, right? So think of it like this. Even if you change a single bit of code, either in the Bootstrap script or the model weights or any of the kernel operating system of that enclave image, the PCR0, the one-way hash function changes. What we do is we take that hash and we simply add it as a conditional in the KMS key policy. And by the way, this is the template of a KMS key policy that I'm showing here. And what we do here is, if I can bring your attention to this one area of the policy called KMS decrypt. So here, what I'm doing is I'm telling KMS that for this particular KMS key, only allow the decrypt action if it originated from an enclave with this particular PCR0 hash. This is just a placeholder value, but the idea here is you add one line of conditional statement to the key policy to achieve the conditional decryption using cryptographic attestation for this particular enclave. So it's that simple.
Essentially, the ID the enclave will present if something changes will not match with the expected ID. That's pretty much it, and the secrets don't get revealed. Yeah.
So exactly. So that okay, you're better than me. Arvin did a even better summary than I had planned to do here. I think I'm really grateful for both of you for coming on to be able to show one, how simple this is. Two, I think everybody understands the importance, or a lot of you have talked to us. Customers have talked to all three of us about the importance of protecting their secrets as they're using them here. And also, I think this is a great example, excuse me, of how simplistic it is to actually get this set up. Now, I don't. We're not on the illusion that you can implement exactly this depending upon the complexity of what you're doing, but I think this is a great way to get started. And for those that come to some of our own events, Reinforce and Reinvent, we offer a workshop where we walk customers through this as well to help you set that up. But I think this is a great way to show people our overall confidential compute story and both dimensions of that story as well. And I want to thank both of you for coming on today to walk through that with me here and to take the time to do that. And if there's anything else you want to leave customers with today, Arvin, maybe you could say in one or two more
I
words.
do. I do. Right. So just a couple of lines here, to leave the audience with. What happens in your EC2 instance is only visible to you, and what happens in an enclave stays in an enclave. Thank you.
And I want to thank all of our audience members for listening to us and learning more about this important topic on security.
Thank you, Art.
Thank you.
Thank you.